algebra students, Mr. Lawrence here, and this should be a real quick video because I'm so worried about that sound not working. Anyway, got a couple sample problems here. Go ahead and try number one. All right, hopefully you've tried it already. Here comes my solution. First thing I'm going to do is simplify inside the quantity. And so I see that 20/30ths is the same as 2/3. Yeah, I just simplified the fraction. Now these x to the negative third and x to the negative sixth, they're going to move, right? Okay. So we're going to send this down, and we're going to send him up, and their exponents will change because a negative exponent means to use the reciprocal. All right, now the y to the fifth and the y to the eighth aren't going to move, so I'm just going to go ahead and simplify them. And it looks like I'm going to get a y cubed in the denominator. Now I'm not really done simplifying here because of the x's, so I better do one more step here. 2/3, and then x to the sixth over x cubed will become an x to the third in the numerator. The y to the third is there, and then we're to the negative second. Now, as we just said, the negative exponent means to use the reciprocal, so I'm going to flip the fraction. We get 3y cubed over 2x cubed, and that'll be raised to the second power, right? Use the reciprocal. There it is. Changes the exponent. Now I'm going to square everything. 3 squared is 9. Y cubed squared would be y cubed times y cubed for y to the sixth. 2 squared would be 4, and x cubed squared will be x to the sixth. Now, supposing I had put a negative in here, let's make that a negative, okay? How does that change my answer? Well, when I went to do negative 3 to the second power, I'd do negative 3 times negative 3. I'd get positive 9. I would still get a positive answer. Okay, make sure you're talking about what the exponent means. It means 3 times 3, not 2 times 3, 3 times 3, right? Okay, number 2, evaluate this. First thing I'm going to do is I'm going to rewrite this. Some of you just take so many shortcuts. Don't take a shortcut. Take the second and rewrite it, and then follow your order of operations. Now, on the midterm, it's okay to use your calculator, but follow your order of operations. Negative 2 to the second. That's 4, so this is really 5 times 4. This is negative 4 times negative 2, which is a positive 8, minus a 10. Okay, one more step in multiplication. I'll have 20 plus 8 minus 10. 20 plus 8 is 28, minus 10 is 18, and there you go. All right, number 3 is done very much the same way. I'm going to rewrite the expression, but wherever I see an x, I'm going to put a negative 3 in its place. So I do my exponents first. So I'm going to have 3 times positive 9. Negative 3 times negative 3 is positive 9. Minus 18. Why did I get minus? Because it would be plus negative 18, which is the same as minus 18. And then I'll have a 1. 9 times 3 is 27. 27 minus 18 minus 1. That'll be 9, I believe, minus 1, which will be 8. And there you go. All right. Don't want to throw too much at you. Now, naming polynomials, right, by degree and terms. So you should be using words like linear, quadratic, cubic, quartic. That tells us what the degree is. And the number of terms, monomial, binomial, trinomial, polynomial for more than 4, or more than 3, 4 or more. And if it's just a plain old number, we call it a constant, like Allie Thompson said in class. All right. So, what is this one here? Well, let's do the degree first. Its degree is 2. That means it's quadratic. Quadratics have a degree of 2. The highest power on x is 2. And there's one term, so it's a monomial. This is all a review. You can always go back and look up an old video to study it, make some flashcards, something. This is quadratic monomial. All right, this one here, the highest exponent is 3. That makes it cubic. It's cubic. All right, there's 3 terms. It's a trinomial. It's a cubic trinomial. All right, this one here, the highest exponent on x is 1. So this is linear. This is a linear binomial. All right, this one here, highest exponent is 2. Makes it quadratic. quadratic because the highest exponent is 2. I've only said that like 8 billion times. All right, how many terms? 1, 2, 3. It's a quadratic trinomial. Very good. All right, this one here, highest power is 4. That makes it quartic. Quartic. Now I know some of you get confused with quadratic and quartic. Just think of quartic as quarters. 4. Okay, and then remember the other one has to be 2. Okay, one's 4, one's 2. Quarters is 4. Quartic is 4. 2 terms, it's a binomial. Binomial. All right, this one here, highest power, 4. Doesn't matter, it's not written in descending order. Highest power is 4. It's quartic. And then the number of terms is 4. That's a polynomial. Once it's over 3, we call it poly. All right. At this point, level 2 students, you can stop watching. You can rewatch if you want. I just want to remind you that my first period class is reporting to Mr. Belkoffer after lunch on Thursday. My second period class is reporting to Mrs. Wagner. My 7th period to Ms. Hamlet. My 8th period class is coming to me. Okay? Just remember that. Don't forget pencil, calculator, etc. All right, I want you to be able to calculate rates based on this graph. We're going to use the equation D equals RT. And so what we're going to do is we're going to look from point A to point B. We're going to see how many miles were traveled, and that would be my vertical distance, right? Vertical would be how many miles traveled. Okay, that's going to be my distance. And I should make that vertical. Looks like it moved on me. Sorry about that. And then my horizontal distance will be my time. So this will be my time, right? Okay, so let's see here. 1, 2, 3, 4. So it looks like I'm counting in 15-minute intervals for time. So it looks like my time is going to be 30 minutes. So from A to B, the time is 30 minutes. Right? We're trying to find the rate, and the distance, it looks like I'm counting by 10 miles. So it'd be 1, 2, 3, 4. So it'd be 40 miles. There's something wrong with this problem, though, because I want the speed to be in miles per hour. I'm not in hours, I'm in minutes. So I'm going to rewrite it as 40 miles, the rate times how many hours? Well, that'd be half an hour, wouldn't it? Half an hour. And so what I'm going to do is I'm either going to divide by 1/2 or I could multiply by 2/1. Right, Sean? All right. So I'm going to multiply by 2 and I'm going to get 80 miles per hour. And that's my rate because over here the 2's cancel. All right. So that's my rate, 80 miles per hour. There you go, from A to B. Let's try another one. Let's try from B to C. That's a hard one. My distance is 0, and my time is 45 minutes. I think the rate from B to C is going to be 0 miles per hour, right? Because I'm not going anywhere. All right, that was a hard one. Let's do C to D. C to D. Okay, C, the distance up, the distance vertical is, let's see, 1, 2, 3, 4, 5, 6, 7. So it looks like this person is going 70 miles. Okay, how long does it take them to get there? Well, let's see. It looks like, oh, half an hour again. So that'll be 1/2. All right, so 70 miles. The rate, the time is 1/2 an hour. Okay, so I should put hours in there. So if I divide by 1/2 an hour, I'm going to end up with a rate of 140 miles per hour. There we go. All right, now, just a minute. Now, from D to E, we're going to go the distance of the distance is 10 miles, right? I don't know the rate. On the time will be 1, 2, 3, 4 an hour. So it looks like 3/2 hours, right? An hour and a half. 3 over 2, 1.5. And so I'm going to divide by 3 over 2, which is the same as multiplying by 2/3. All right, and so I'm going to get 20 over 3, which ends up being 6 2/3 miles per hour. Maybe this guy's caught in a traffic jam. Yeah. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.